Welcome to the House of Maths. Today I'm going to look at the area of a triangle. So here's our triangle. Now, if we want to find the area of this triangle, one of the easiest ways to do this is to create a rectangle around the triangle. Now I'm going to drop a perpendicular there. Now if I call this B for the base and I call that H for the height, hopefully you can see that the area of the rectangle is just B times H. And hopefully you can also see that the triangle is half that. If you take this section here, we've got a diagonal from corner to corner. These two sides are the same. And then from here to here, we've got a diagonal here. These two sides are the same. So the area of the triangle, if I call it T for triangle, is going to be half. Okay, so our area of the triangle is half base times height. So in order to calculate it, we've got to have the base, we've got to know what that is, and we've got to know what the height is. And then we can just use this formula here, which I'm sure most of you are familiar with. But what happens if you've not got the height of the triangle? Okay, so here's another triangle. Let's just assume that we've got these measurements. Okay, we've got those measurements. So we've got the base, we've got an angle, and we've got one of the slope sides there. And we want to find the area of this triangle. Well, you can see we've not got the height. We want to use that idea. We've got the base, but we've not got the height. So what we could do is find the height. So if we drop perpendicular down here and create a right angle triangle here, we can use SOHCAHTOA to find the height. I'll just label that H for height. So hopefully you can see that we're going to use the sine here. So I'm saying sine theta equals opposite over hypotenuse. Hopefully you remember that from SOHCAHTOA. So here, let's put in what I've got. I've got sine 50 equals H, what we're after, hypotenuse is 12. So if I just rearrange that, I'm going to get H equals 12 times sine 50. Okay, that will give me the height. Then once I've got the height, I can use this formula over here. So I'm going to put that in. I'm going to do half times the base, which is 15, times the height, which we've just got here. And that would then give me the area of this triangle. Now let's just consider a general form of this triangle. Okay, I'm going to call this length here, I'll put it in a circle. Let's pretend that side is B, this side here is A, and this angle is theta. So how would that relate to what we've got here? Well, we've still got the half. We've got half times, should have written these the other way around, shouldn't I? I'm going to do half times A times B times sine 50. Okay, I don't really want the 50 there either. We're still dealing in generalities, so let's call it theta. So this is the same as this. Okay, so that gives us the area of the triangle as half AB sine theta. And that's going to work for any non-right angle triangle or any right angle triangle. You wouldn't need to use it with a right angle triangle. Doesn't matter what the triangle looks like. So here's another triangle here. Okay, let's say we had this angle here, this side here, and that side there. We could use this formula to work out the area of that triangle. Now notice that you've got the angle and you've got the two sides adjacent to that angle. So you're going to need those two sides in order to use this formula. What happens if you've not got those? Okay, let's say we've not got that side and we've got that side instead. Well, we can't use this formula as it is at the moment, but we could find more sides or angles in that triangle and then get the ones that we need in order to plug them into this formula. So, I mean, I've got these two sides here, so what I really want is this angle down here. Now, I can see we're going to have to do a bit of trigonometry, we have to use a bit of trigonometry to get that, but we can do it. I notice here that I've got a side and an angle opposite it. I've got a side here, and I could get this angle over here if I call it theta. So I could use the sine rule to get this angle. So remember, the sine rule is sine A over A equals sine B over B. And once I've got that angle there, we've got a triangle here. We'd have two angles that we know. We could then find, call that one alpha. We could then use the fact that we know that angles in a triangle add up to 180, and we could find this angle. And once we've got that, we can then use our formula to work out the area. So depending on what you've got, what sides and angles you've got on a triangle, you might be able to go directly to using this formula, but you've got to make sure you understand that in order to use it, you've got the angle and the two adjacent sides so that you can directly use this. If you've not got that, as we had in this example, you are going to have to do a little bit of work to maybe find, in this case, this angle down here, which we used the sine rule to get this angle, and then the fact that angles in a triangle add up to 180 to get this one, and then once we've got that one, we can use this formula to work out the area of the triangle. Okay, that's a quick look at how to find the area of a triangle. Hope you enjoyed that. If you did, hit the like button, and more content coming soon.